Ready? Three-dimensional figures are also sometimes known as space figures. So if you see the word three-dimensional figure or you see the word space figure, you know you're doing the same thing. So the first one we're going to talk about is a prism. A prism has two bases that are parallel and congruent to each other. And what does congruent mean, Kayla? They're the same. So what it means is that prism is going to have two bottoms, or a bottom and a top, that are identical figures, and they're the same distance apart. All the way away. All points of them are the same distance apart. So they look identical top to bottom. Every side will have the same height measurement. That's what that means. The faces are also parallelograms, meaning that they're like a rectangle or a square, right? Those are the sides of it, the faces, not the bottom and top, but the sides. And then you name the prism based upon the shape of its base. So here is your example. The shape of the base is what, Max? What is this shape right here? What is that? A pentagon. And so we call it a pentagonal prism because we see that there's a bottom and a top that are identical, and we see that there is a parallelogram on each side. So there's a rectangle in essence on each side. So we call it a pentagonal prism. That's your first three-dimensional figure. Then your next one is a pyramid. And the pyramid has one base. And then it has triangles on its sides that meet at one single point. So this is the top of your pyramid. Okay? So the base is what? What is the base of it? What does the bottom of it look like? A rectangle. And what's a rectangle's polygon name? How many sides are on it? 4, so we call it a quadrilateral, right? So it's a quadrilateral pyramid. And the reason we know it's a pyramid is because the sides are all triangles that meet at one point. It does look like a box with an X. You got to kind of have some visual stuff. If we had a 3D TV, you could put your glasses on and that pyramid would come pointing out at you. Okay? They haven't hooked me up with the 3D TV yet, darn it. Questions on a pyramid. So pyramid only has one bottom, has no top, and it has always must have triangles on its sides. Okay? The next two, the first one is a cylinder. This has circle at the bottom, circle at the top, and they're the same size circles. So when we ate our pie on Monday, were we really working with a cylinder? No, but we faked it, right? We pretended we were working with a cylinder. And those circles are always parallel to each other. So they're always going to be the same distance apart no matter where you measure the height at. All right? That's a cylinder. And a cone then has one base, and that base is a circle. And we're going to see if Mrs. Miller has any drawing skills. Not so good so far. And then it meets up at a point. You all know what a cone looks like? Because I know you've all eaten ice cream cones.
Yes.
Sugar cones. Right? The sugar cone is the real cone. The whatever the other one's called is not. Well, waffle cone is a real cone as well. Because it does the same thing. It has a top that's a circle. And then the bottom. Yeah, what are those flat bottom ones called? No, sugars are the cake cones, I think. Something like that. Okay? So we all know the cone, right? Questions on the 4 types of three-dimensional figures? Anybody? All right, so now we're going to get to naming them. All right, so this is how we're going to name them. Everybody listen, because this is part of your assignment. Name the base. What is the figure on the base? Then name the figure itself. And then name the part that's labeled RL. So, who can tell me what the base is called? Garrett? A circle. And what is the name of our figure? Connie? And then what is RL? Katie? Nope. Kelsey? The radius. So we would label our answer like this. Circle, cylinder, radius. Pretty simple, right? Everyone can do that? You cannot read that in pink.
Nope.
Darn it.
Looks like a line.
Well, if you go online and look at the notes, you can read it. There you go. All right, so the next one. What is the base called? No. Sam. Kelly. Katie. The base, I know this is this is when it gets confusing, right? But the base is actually here and here. Why is it not on the bottom? Because then it wouldn't be a three-dimensional figure, because the faces of a three-dimensional figure, of a prism, have to be quadrilaterals or parallelograms. Does that make sense? There's kind of some rules to it, I know. So it is a what? It's a trapezoid. So then what is the name of our figure? Haley? So if the base is a trapezoid, what is our figure's name? It has to have a part in front of it. We name it by the figure. What is the figure? And then you say, thank you. And then what is RL? What is that line right there? This is kind of tricky.
Hi.
What?
Hi.
It is actually called the lateral edge. Oh, what, Mrs. Miller? I know. That's why I'm showing it to you. So this is the edge. So we have a trapezoid, a trapezoidal prism, and then we have a lateral edge. Because it's the edge of the prism. And lateral is up and down. Like a ladder. Get it? If it would have been RL here, we could have called it a horizontal edge. Right? Does that make sense?
I think.
You think? Kinda? Up to that one. Okay, so then we have the word skew. And a skew is when a line doesn't intersect or doesn't or is not parallel. So we can have two lines that we call skew when they don't pass through each other and they're not parallel to each other. So line segment AH and line segment CD are skew because they never cross each other, they never meet up, and they're not parallel, right? Does that make sense? Because that's one of the parts of the assignment is to say if it's a skew, if it's parallel, or if it intersects. So these two are not parallel. These two are parallel. So if it would have been AH and then G and F, that would have been parallel. But these two are not parallel to A and H. Okay, does that make sense? So easiest way to see it, they're not meeting up. They don't share a point, and they're not straight across from each other. That's skew. All right. So then a polyhedron. Oh, Mrs. Miller, a polyhedron? Really? This is really simple. Any figure that has a polygon in it that's three-dimensional is called a polyhedron. So, here's my question to you. Is that a polyhedron?
Yeah.
Is that a polygon?
No.
So is that a polyhedron?
Yeah.
No. It has to have a polygon. A circle is not a polygon.
Oh.
It is not a polyhedron.
Come on, Katie.
Is a cone a polyhedron?
No.
No. Is a pyramid a polyhedron? Is a prism a polyhedron? Does that make sense? All right, so now real world problem. Ready? Are we ready?
Yeah.
We're going to get through all these notes. I'm so happy. Here's a birdhouse. I want you to tell me what three-dimensional figures are on this birdhouse. Anybody? Kelsey has an idea. Kelsey, hit me with it.
I know.
Which one?
I know 2 of them.
Okay, there's only 2. So tell me what 2.
There's the pentagon for the...
It's not a pentagon. We're looking 3D. So what is it called? It's called a pentagonal. A pentagonal prism is number 1.
And then,
Kate, hold on. Katie B is going to do number 2.
and the cylinder.
And then the cylinder. So this is a pentagonal prism because it's 3D, right? And its base is a pentagon and its other side is a pentagon. And then this is a cylinder. So if they showed you a picture like this and said label the 3D dimensions in this picture, you would say pentagonal prism and a cylinder. How many of you think, oh, no problem, Mrs. Miller, I can totally handle it? Yeah? All right, here's your assignment. Don't freak on me because you're going to work on it tomorrow and finish it in class tomorrow. Yes. There will also be a worksheet tomorrow that will be due on Friday. So homework tomorrow would be a worksheet. Does that make sense? No homework tonight. 4:30 and 4:31, you're going to do it in class tomorrow. Yes. You're not applied math 2. That's yours.
No,